Hello, everyone. Welcome back. Good morning. I'm Steve.
And I'm Scott.
Together, we are Backyard Musings, the science and technology channel.
Yeah, and we are talking about another space topic this morning. So strap in.
So, if you're wondering why Steve looks different, it's because it's a long story. My laptop, one of the video ports wasn't working, and I got to have two monitors. So I ended up sending it back. Short story, sent it back to the manufacturer, and then my wife's laptop is slow as molasses. I mean, painful to get anywhere on it, just to boot it and get the internet and get. It's just slow. So I'm on my iPad, which is light speed faster.
Yeah, his
So
his his laptop was repoed. He spent too much money for it.
too much money to let that go past with something not working.
Yeah, exactly.
So yeah, so here we go. New Mars Express images show grooves, ridges, and crater patterns carved by ancient glaciers. You heard that right, ancient glaciers. These icy flows once reached well into Mars' mid-latitudes, far from the poles. Their presence reveals powerful climate shifts driven by changes in the planet's tilt. So we could call that climate changes, right?
Sure, I guess. Better on
To-
Mars than here.
Together, these features offer one of the clearest records of Mars' icy past. Would you like to know more?
As we travel from Mars' equator towards the planet's northern regions, we arrive at Colo Fosse or Fosse.
Sounds Italian.
Yeah, the landscape, this landscape, maybe they've been there already. This landscape is characterized by the long, shallow grooves that cut across the area filled with steep valleys, scattered impact craters, and surface clues left behind by an ancient ice age. Earth has gone through several ice ages over the past 2.5 billion years. The most recent one, which reached its peak roughly 20,000 years ago, lowered Earth's global average temperature to around 7 to 10 degrees Celsius, which I don't know why we refer to it Celsius, but anyway, up to 8 degrees Celsius cooler than today. So, okay.
Yeah, so how do they know that?
I,
How do they know 8 degrees cooler than today?
yeah, I don't know.
They have a thermometer
Who,
back then, then they pulled it
who,
out of the time capsule?
who knows? Yeah, I think this is, yeah, a lot of guessing. It's kind of like the weather.
Yeah. These long term freezes differ completely from today's human driven warming trend. Their words, not mine.
Yeah.
Ice ages arise from slow natural cycles tied to shifts in a planet's orbit around the sun. That's true. And changes in the tilts of its rotational axis. That's true. When an ice age begins, glaciers and ice sheets expand, and as temperatures fluctuate, these ice masses repeatedly advance and retreat. True.
We're going to need to talk to the producers about some of this global warming stuff or Mars warming stuff or
They were
whatever.
limited by resources last night when they put these notes together.
Okay, yeah, we're not complaining. We just need to have a sit down. other other planets show similar patterns. Mars carries its own evidence, and the newest views from the high resolution stereo camera on ESA's Mars Express reveal how strongly these cold periods shape the planet. A set of nearly parallel lines cuts diagonally across the terrain. These features are colophosae, formed as alternating blocks of the crust drop downward over time. The surrounding landscape contains numerous craters created by cosmic impacts. They vary widely in shape, size, and age, with some sharply defined, others eroded, and many overlapping or clustered together. Okay.
You know what would be really cool is if we could somehow film a crater, a comet impact on Mars. That
Yeah.
would be
Someday.
breathtaking.
Someday.
Yeah. Well, dangerous too. Within the valleys and crater floors lies something especially revealing swirling, textured patterns that show where icy material once moved during a past Martian ice age. These patterns provide direct clues to Mars' earlier climates. Scientists classify them as lineated valley fill in
Hmm.
valleys or concentric crater fill in craters. They formed when slow-moving mixtures of ice and debris crept across the landscape like glaciers on Earth
Yeah.
and were eventually buried up beneath thicker layers of rocky material.
This raises a surprising question because the region sits at a latitude of 39 degrees, was that north?
North, yeah.
It is far from Mars' North Pole at 90 degrees north. So why did ice accumulate here? The explanation lies in Mars's long cycle of advancing and retreating glaciers. Although the planet is dry today, although we've talked about ice under the surface, right?
Yeah.
It has gone through alternating warm and cold phases throughout its history. These shifts, driven mainly by changes in the tilt of its axis, cause repeated episodes of freezing and thawing. Okay.
So here's an interesting question for you, Scott. And just because of our religion, we're thinking out of the box here. Wonder if, because these ice ages are thousands and thousands of years, and we know that man has only been on the earth for 5,000, 6,000 years. So I wonder if Heavenly Father specifically put man on earth during a period of the ice age where the climate's favorable. I'm wondering if that probably goes into the thinking process.
Yeah, I don't do that very well.
No.
So,
Okay.
but it's it's all part of the plan. We won't know until we get to have a chat. But yeah, those are all questions that I guess we should tuck away and bring that up. And he's going to go, with all your life experiences and all the things you've gone through, that's what you're interested in. Anyway,
so
here we go.
Do you want me to bury it deep in the vault until we get to heaven? Is that what you want me to do? Deep in the vault?
Okay.
During colder intervals, ice spread from both poles into the mid-latitudes. When the climate warmed again, the ice retreated but left behind clear geological traces. Lineated valley fill and concentric crater fill appeared across this entire latitude range, indicating that the planet experienced a significant global climate shift. This region may even have been coated in ice as recently as 500,000 years ago, marking the end of Mars' most recent ice age.
These features, along with the colofossae and the nearby craters, are highlighted in the annotated imagery. The broader maps also show the division between Mars's northern and southern terrains. This divide wraps around the entire planet. In some areas, it forms a steep cliff nearly 2 kilometers high, while in others, including this region, it appears as a wide transitional zone that has broken apart over time, known as a protonoless mensae. Okay.
Yeah, we talked about Mons Olympus that has that cliff at its base for miles. This is fascinating. The Mars Express high-resolution stereo camera was developed and operated by the German Aerospace Center Deutsche Zentrum für Luft- und Raumfahrt, DLR. The systematic processing of its data took place at the DLR Institute of Planetary Research in Berlin-Aldershof. The working group of planetary science and remote sensing at Freie Universität Berlin created the final image products presented in the article that they showed us. Fascinating.
I'm glad that segment was for you, because I would have butchered some of those.
Some of the German
words. Yeah. Butchered is probably a kind word. So anyway, yeah, pretty cool story. This is going to be the next. We got still a lot of stuff to do on the moon, but this sounds like this is going to be the next big exploration. This is what they're pointing towards. So
yeah,
cool that they're finding all this stuff out.
Head out to Jupiter, to one of the moons of Jupiter.
Yeah, just a hop, skip, and a jump. So
through that asteroid belt. All right, folks, thanks for joining us.
Take care. We'll see you this afternoon.